Okay, this is the first installment of the lecture on attention and consciousness. This will be split into two. This is the last lecture of this course. We are now coming to the edge, where the sidewalk ends, if you will. These are some topics that are on the frontier of science. Neuroscience is definitely one of the very exciting frontiers of scientific exploration. And these are questions that we don't have a lot of answers to in a lot of ways. So this is really the frontier. Your mind may be blown today. Here's just a question to give you a little sample of the kind of mental gymnastics we sometimes have to do to try to grapple with some of these concepts. So here's a question. Which one of these is conscious? Supercomputer built by IBM called Watson that can win at Jeopardy. A hydrogen atom or John Cena. So maybe you say one of the three, two of the three, at least according to one consciousness researcher, David Chalmers, all of the above are conscious. Now, the degree of their consciousness varies. Of course, John Cena would be the most conscious among these three, but even the hydrogen atom has some degree of consciousness. This is one way to kind of get at the hard problem of consciousness, that consciousness is a fundamental property of matter, just like inertia or mass. So, key terms you'll need to know: dualism, monism, inattentional and change blindness, and spatial neglect. Should be able to describe, not solve, the easy problem and the hard problem of consciousness. Explain these phenomena: binocular rivalry, masking, flash suppression. These are phenomena you can observe with these tasks that provide insight into conscious experience, the consciousness of stimuli. Attentional processes, contrasting top-down and bottom-up. And then we touched on EEG briefly in a previous lecture, but we're going to get a little bit more in depth with this. Okay, so dualism, that's the idea that the mind and the body exist separately, that the mind is a different form, is of a different substance than the brain and the body, and that the mind is neither matter nor energy. This is an idea espoused by René Descartes, a French philosopher. He believed that these two dual substances, the mind and the brain, although they're separate, they do have to interact at some point, and he believed that it was the pineal gland where they interacted, because that was the smallest structure that he could find in the brain that was not duplicated on both sides of the brain. He thought that that must be the logical choice. Monism is that the universe consists of only one kind of substance, matter and energy. Of course, matter and energy are related. And there are three flavors of monism. One is that minds don't exist, or that only minds exist. Good luck with that one. Or the mind is what the brain does. The mind is brain activity. You may remember Thomas Hobbes. He was a British philosopher, and that was kind of his idea, that the mind is what the brain does. So which one's correct? Well, neuroscience can't technically answer that. Since something that's non-matter and non-energy isn't something that we could objectively measure with the instruments that we have, can't really get at that question. But neuroscience research, biopsychology, typically progresses along the monism premise that you can study the mind by investigating the brain. Okay, the easy problem and the hard problem of consciousness. The easy problem is still not a very easy problem, but it's easy compared to the hard problem. And that gets at questions like what needs to occur in the brain for us to be conscious. Conscious versus awake and conscious versus asleep, versus unconscious, versus in a persistent vegetative state, versus locked-in syndrome. And also to consciously perceive a stimulus, that you are conscious of something that occurs in the environment such that you can talk about it, you can report that you saw it or that you heard it. The hard problem gets at questions like this. Why are we conscious? Why do we have a subjective experience? Why is there something that it's like to be a person? And is there something that it's like, what is it like to be a bat? For example, that was a question posed in a famous paper on consciousness. What is it like to be a bat? Do they have some conscious experience, some subjective experience of the world? And how would it be different for them versus us? Why do we have this narrated movie playing in our heads of all our sensory experiences that is integrated into this whole? How does that subjective experience arise from the flow of ions across a membrane? Action potentials and synaptic transmission, how does that translate to this subjective experience? Why aren't we simply robots? Why does this processing not all happen in the dark, as some research, as I believe David Chalmers put it as well? Why doesn't it all happen in the dark? Why aren't we androids, zombies, robots, just taking in input, producing output without any subjective experience? And then also this question, I don't know if you've ever thought of this. We are trying to study the brain, but we are using our brain to study it. Can brains even study brains? And our heads explode. Okay, so these questions relate to the hard problem of consciousness. So the current thought is, let's try to tackle the easy problem, and then maybe that'll provide some insight into the hard problem. But there are some philosophers and other scientists who are trying to get at the hard problem of consciousness. What are the neural correlates? What are the regions in the brain that seem to be related to our subjective experience? Inattentional blindness. There's a really cool demonstration that I don't know if I'll be able to really show. It's I'll post a link in the description. You'll need to go to a specific time point in the video. It's rather long. It's a long lecture given by a Princeton professor, Dr. Jonathan Cohen. And it's the talk is about not about attention per se, but he gives this little demonstration of inattentional, or of change blindness, excuse me. And this is, it demonstrates that you're only conscious of stimuli that you attend to. I won't explain what he demonstrates, just so I won't give it away. But change blindness, if there are slow, gradual changes in a complex scene, you're not going to be conscious of them unless you're specifically attending to them. Inattentional blindness is very similar. That's where if there's some salient stimuli, some very relevant and eye-catching stimuli in the environment that you're directing your attention to, you might not notice something else. There is something that your attention is not directed to. So maybe you've seen those videos of the gorilla that walks through the room while you're trying to count the number of passes that a basketball team makes. Attentional processes are sometimes divided into top-down versus bottom-up. Top-down is the intentional directing of attention. So that's kind of a cognitive control-related process. Bottom-up attention, that's where you don't have to try, but the stimuli just grab your attention. So this is where you're trying to focus in on something, attending to something, and this is where a stimulus just grabs your attention without even trying. Flashing lights in your rearview mirror, even if you're trying to pay attention to the road, those are going to capture your attention by bottom-up processes. Spatial neglect is a fascinating syndrome that occurs in stroke patients, in which these patients with right hemisphere damage will ignore the left side of space. This right parietal damage tends to lead to this. And these are some drawings of that have been produced by spatial neglect patients. When asked to draw a clock or a house, they'll draw it, but they'll just leave off the whole left side. And it's not blindness. It's not that it's not like the left side of their world is just black. They're just not consciously perceiving it. There's no the sensation is intact, but the perception is disrupted, and it's ignoring the left side of things, not just vision, but they'll also they may just shave one half of their face and only dress one, only put a coat on one side of their body, for example. When they eat food, they may only eat one half of the plate, and if you distract them for a second, then turn the plate 180 degrees, they'll think they have a full plate of food again. So it's a really interesting phenomena that also provides some insight into what areas of the brain may be involved in the conscious perception of stimuli.